don't know if you guys pick up on the fact that this follows order of operations, right? Because in order of operations, what would we do first? We would do this first. And yes, this is the goof function. So if I see this notation, I can rewrite it how immediately? G of f of x. Order operation says do the inside first. Okay, well, what's f of x? Square root of x minus 2. I like it. Let me put this up. So this is g of the square root of x minus 2. And what does the g function do to stuff? Squares it. So I take the thing and I square it and I add 5. I like it. I love it. I like it. How's that? I mean, let that be okay. I mean, we all should know function notation. We got to know that it just means substitution on a basic level. Right? Just substitute. Whatever the hell's in there, you substitute. This is going one step back from what we're used to. We're not calling it what it is. We're calling it F. And we're like, all right, you stupid, crazy. You meant this. Okay, I'm going to throw that in there. Right? Real quick follow. One star. A little follow-up on number 1. So what if I had said, what is G of F of 7?
7 minus 10?
Yes, it's 10. Because what's g of f of x? What's g of f of x? Then we just figured out what that is?
3.
It's x plus 3. So this is one reason why they wanted a notation that looked like this, because that is its own function now. When I put f into g, I get this function. So what's the g of f function? X plus 3. So then what's g of f of 7?
7 plus 3.
Freaking 7 plus 3, so 7, Jeff. 10. Do you guys... You're creating a new function. So they wanted it to look like f of x, g of x, something of x. So they're like, what are we going to put in there? F of g or g of f? Right? So you're making a new function by throwing a function inside of a function, right? Functionception or something. A dream inside a dream inside a dream. That was Inception's theme song, if there were. All right. So the same kind of thing could happen with f of g. What is f of g? So that would be f of...
Square root of x squared plus 5
yeah,
plus 2.
I like it. So this is f of the x squared plus 5, because that's what g is. And the f function takes whatever's in it and throws it under the square root symbol. So that gets put here. Let me stop there for a second. Is everybody kind of with me? So the f function has to have this form. So instead of x, I'm going to put this. That's all I'm doing, really. It's just substitution method. It almost, I just said it like that. It almost feels like substitution method, right? Taking one function and putting it into another. That's exactly what we're doing. And of course, I end up at
X squared plus 3.
coolness. Coolness. All right. So if I said, what is f of g of 1? It would be the square root of 4, which is 2. Because we know what the f of g function is. It's this. So you just plug it into that result directly. So the homework will have this happen. They'll say, what's f of g of x? And then what's f of g of 7? Just plug this 7 into what you just did. You just did all the work. Okay. So this isn't that far away from what we've already done with functions. The next level is now talking on a different level about functions. Was there something? I can't remember. There was something else. Oh, yeah, that's right. Before I get too far away from this, using those same two functions, what about, this always freaks people out, but I don't blame you. What about this? What's the goog function? What does that mean?
G of G of X.
G. Yeah. So it says take G and plug it into itself, right? So don't take it too far. So G of x. So G of what? G of, what's that? What's G of x? X squared plus 5. So what does G do to something? It doesn't even matter if it's self. It does the same thing to everything. It takes that thing and squares it and adds 5 to it. Well, what's the thing now? So I'm plugging x squared plus 5 into x squared plus 5. So in place of the x, I'm going to put this whole thing. Bam. So don't let that freak you out. It's exactly the same as these problems. Don't go, G is G. No, G is its own thing. Plug it into the G function and then simplify. So here I'd have to do what? Foil, and you can do that. Yes? Oh, all right, let me make this. All right, here we go. So for these problems, G of anything is that thing squared plus 5, right? So G of x squared plus 5 is going to be that thing squared plus 5. That's one. What does G do to anything? It takes that thing, squares it, and adds 5 to it. That's what it does. So what's it going to do to itself? It's going to square itself and then add 5 to it. So that's a really good question. I like it because this kind of problem, you said, I already wrote the plus 5. Well, I need another one because you didn't write the plus 5 for the outside G. That's the plus 5 for the inside G. Don't think about it like that. It's a little too technical, right? Okay. I like doing what I just did. When you do this kind of thing, you say G of anything is that thing squared plus 5, and then you write whatever they ask. You write it right there. I mean, that's another way to kind of attack these problems. So then you don't forget stuff like that. It's already sitting there waiting for you. Okay. So let me give a little preview. We'll take a break. It'll give me time to print out a handout that I have for this. My whole world has been finishing up preparing the test this morning, so it's good to have some time for that. Okay, good. All right, so let me ask you a silly kind of question. If the function f is x minus 5, what do you think the inverse function of f would be?
X plus 5.
Kick ass, I love it. It's not 1 over x minus 5, right? And you see why, I mean, that's a really easy, understandable thing to think, because we think inverse means flip, but inverse means opposite of. So I want the function that will do the opposite of what this function does. And what does this function do to anything? Subtracts 5. So it makes sense that the inverse function would be x plus 5. And we just need a notation. Now here's, again, another thing. The whole fog function thing, that's a day that I wish I wouldn't have existed way back when I went, let's think about this a little more. Here comes another one. This is so evil. Here's the notation we use for this. So we say the inverse of f is this. Do you see why this notation is really evil?
Yeah.
Because that really makes it look like it's supposed to be 1 over. You have got to remind yourself that what this means is the function that does the opposite of what this one does. Whatever f is the function that does the opposite. So what if I had g of x is 7x? What would g inverse of x be? Yeah, what does this do to x? It multiplies by 7. So what should the inverse do to x? Divide by 7. So it still wasn't 1 over. What's 1 over this? 1 over 7x. That's not the right answer. That's not the function that does the opposite of what this one does. So I know this notation makes it feel like we're supposed to flip, but that's just unfortunate decision on notation, right? Any of you guys ever watch Silicon Valley? Some of you guys? All right, I'm sorry, that's a bad example. If you have engineers construct something, they'll love it, and then you give it to normal people, they'll be like, what the hell is this shit? It's beautiful, everything works perfectly. I don't have a clue that. So this the math people, they're all math people. Like, we know what that means. It sounds great to me. And then we give it out to the regular people, and they're all like, well, what the hell's that shit? So it's too late to go back and switch this. Everybody in the universe thinks it's this. Oh, too bad for us. You just got to remind yourself this does not mean flip. I know, and you're like, Jeff, you've been drilling it in our heads that that's what that means, and I'm sorry. I wasn't around back then. All right, so what we're going to do with this, that's a very simple idea, right? But I wanted to lay the groundwork of what inverse function should mean, and now we're going to start to get really into it. What if the function was this? How would we figure out this guy's, let me make it even more interesting. What's the inverse function of that? We can figure out what would it involve. What should the inverse function involve?
Adding 2.
It's good. Adding 2 should be there somewhere.
Dividing.
Dividing by 2 should be in there somewhere.
Adding 7.
Not the square root of 3, but the cube root. Right? And adding 7. All those things should be in there. What order should they be? Oh shit, so we're going to develop a process that will make them all show up in the right order. We kind of know ahead of time what should be in it. What should be in the opposite of this? All the opposite shit. But I need a process to make sure that it actually kind of goes in the right order, right? So that's the next thing we'll talk about. So let's take a break. Come back at, I'll give you till 1. Why not? We've done a lot of shit. So go take a nap somewhere, a little power nap. That'll give me time too to